Well, welcome to the Home Lab, and to celebrate my recent achievement of 3,000 subscribers, and thank you to all of you for that, I've got a really unusual video for you today. You all know about drawing pictures, you all know about music, and some of you will know about how to use an oscilloscope, but what happens when we combine the three and use music to draw pictures on oscilloscopes? So let's get started. This all came about with a project I've been trying to do for a long time and I haven't got round to it, and that's to use an oscilloscope tube, a cathode ray tube, to draw a clock face on it. So you're using an oscilloscope to draw a picture. And I was fiddling around on the internet and I came across this chap called Jerobeam Fenderson, who calls himself a sound artist or an electronic sound artist. So I had a look at what he was doing and I downloaded and paid for some of his music. And what I realised he was doing was feeding music into the two channels of an oscilloscope and displaying them so they displayed quite incredible pictures. So I've got a download of some of his music and I've got a little electronic device I can use to feed the sound into the oscilloscope. So let's have a go and see if we can get this to work. So what I'm going to use is my trusty Hameg oscilloscope, cathode ray oscilloscope, not a modern one with a liquid crystal display. And I've bought a little MP3 player. You can run these off a USB port. I think I'll just run it off the lab power supply. And a little SD card there. They take, I think, up to 32 gig, but I've got a 16 gig card in there. I've put the MP3 files on it, and this device allows me to increase and decrease the volume, and it's also got switches that will skip tracks or stop. And I put a little loudspeaker on it just so we can hear the music. And what we'll do is attach it up to the oscilloscope. But before we do, we need to understand a little bit about how we're going to configure the two channels on the oscilloscope. Right, so I've tightened up the screws on my lab stool so it's not quite as creaky and squeaky as it was. So let's have a little brush up on the oscilloscope, and particularly the XY mode that we're going to use it in. I haven't currently done a video on Lissajous figures, and if I had, then this would make a little bit more sense. But I think you're probably all aware that an oscilloscope of this type has two channels, and you can switch on both channels and measure two different voltages and compare them, add them, subtract them, etc. But we're going to do something slightly different. What we're going to do is use the first channel to measure voltages and move a dot across the screen depending on what the voltage is. So as the voltage gets higher and higher and higher, the dot will move further across the screen, and when it gets more and more negative, it will move to the left. And then we're going to use channel 2 to connect to the Y plates in the oscilloscope. So what that will do is drag the dot up and down depending on voltage. So this is a slightly different use. So we're going to feed in 2 different voltages that are constantly changing. They're going to be the left and the right audio channels. And the left channel's audio, which is going to vary between plus and minus, is going to move the dot backwards and forwards on the screen. And the right channel, that goes into channel 2 on the oscilloscope, is going to cause the dot to move up and down, with 0 volts being in the middle of the screen. So you can imagine we're going to get a complex pattern of the dot moving from side to side and also moving up and down at the same time. So let's get our little MP3 player wired up and see what it looks like when it's working. Okay, so here's our little MP3 player. I tend to keep projects with all the bits together in these little boxes. It's quite handy so you don't lose anything. So we'll just pop it out, and there it is. I notice I've written 16 gigabytes on it, so that must be the biggest card that it can take. And the first thing I need to do is just very quickly solder on a couple of pins to connect the 5-volt power supply to it. There is an option to stick a USB in, but I think I prefer to power it off the lab power supply. Okay, that's that done. So I'm not very good at soldering with the camera in the way, but let's turn it over. And what we need to do now is quickly connect the power supply, connect a loudspeaker so we can hear what's going on, and then we'll put some leads onto the oscilloscope, the XY position selected on the oscilloscope, and we'll drop in the memory card, and let's see what it sounds and looks like. Okay, so on goes our little loudspeaker. So what we need to do now is just connect up some power, put the memory card in, and then connect up to the oscilloscope. Okay, so let's get the power supply hooked up. So turn on the power supply, and the voltage to the terminals at the moment is not on. We've got the negative there, the positive here, and just a little trick. You'll notice in a second I've got a little LED here that I connect to the 5-volt output of the power supply, and that's because with this power supply you can leave the voltage turned up considerably and then press on, which I find really annoying, and then burn out the electronics you're working on. So I try to remember to turn that all the way down, and when I turn on the power supply I get this flashing LED that says to me, you know, be careful that you haven't got the voltages dialed up too high. So here we go, we want about 5 volts, very low current. There we go. And that should be enough to get our little unit working. Okay, just to show you that the unit's working, I've got the mains on the power supply turned on, but the output voltage off. I've got it dialed up to 5 volts, so let's just turn on the output voltage, and there we go. We get a red light on the unit, so we know that it's working properly and it's powered okay. So I'll just turn it off, and we'll connect up the oscilloscope. So just before we head off to the oscilloscope, you'll notice the board has got these little switches on them, and these are the ones that allow us to increase the volume, decrease the volume, go forward or go backwards a track. So I've put the sound files onto this little card, so I'll pull it out, and that's the card we need to put in here. And in it clicks, so we're now ready for our connections to the oscilloscope. Okay, so sound output from the devices here, and you'll notice it's stereo, and that's really important, and it's important we get a good earth. And then we'll connect up to the oscilloscope. So here's one channel and here's the other one, and it's actually important which way around you get the probes, but we can deal with that later because sometimes you get an image that shows upside down. So that's one connected, that's the other one connected, and then we will just connect an earth to here. It's easier said than done, and I don't think we really need the second earth, but let's do it anyway. Here we go. Is that going to stay on? Yep. So we've now got everything connected, so we can turn on the oscilloscope, and in a second we will press the XY. There we go. And we'll switch on the unit and we'll see what we hear and what we get on the screen. Okay, we're all connected up and ready to go. So let's turn on the power supply and see what we get. So I do hope you enjoyed that. When I first came across this, I was truly astounded. I think it's one of those interesting bits of electronics physics where if you don't know anything about science and physics, it's pretty patterns on the screen and it's fantastic and it's very enjoyable, but you don't get that, that's incredible, how does that work? And then when you know a bit more, as I'm sure you do, about how oscilloscopes work and how they measure voltages, it gets harder to understand. You look at it and you go, how does he do that? How is that possible? And I played through all the different tracks and thought, crumbs, and drawing shapes and shapes rotating and sort of firework patterns and things like that, and people riding on bicycles. How is that possible? And for those of you who know a little bit more about oscilloscopes, we're not even using the Z modulation. So we're not using a socket that's usually at the back of some more advanced oscilloscopes, which allows you to brighten and dim the trace. In other words, you could draw a partial line and then switch it off and then have it come back on again. The Z axis, it sort of stops the electron beam hitting the front of the tube. Anyway, I really do hope you enjoyed that video and found it as interesting a topic as I did. Just before we go, yet again to say thank you for making all of this worthwhile. I really enjoy doing it. I hope you like the home lab. Tell me if you like videos being made here. And most of all, thank you for supporting me and bringing the channel, little channel that it is, up to 3,000 subscribers. Anyway, I'll be making another video soon, and I look forward to seeing you then.